Okay, so let's start with the idea of what are inferential statistics. And to know about that or the basics before we actually go to some analysis is that we should come here with a hypothesis. We talked about hypothesis in the last lecture, which is inferring or coming up with kind of a proposition of a relationship or causality between variables. Like we have to come with an idea. That is something very important. It's not the best if you come with, let's see what happens. That will lead to very weird results, or I don't know, it's not the idea. So it is better if you come with some hypothesis, like you have one, because now we are talking about two variables, right? Like all of the descriptive statistics are single variables, right? You are focusing on analyzing one variable, either because you only have one or because you are analyzing all of your variables, but independently. But here is not like that. Here you have at least two variables. So you should come with an idea of what will happen in that relationship. So first thing, the hypothesis. You should have a hypothesis from before. The next thing is that you should try to think if it is possible that you understand which variable which affect the other. Like the dependent variable is the variable that will be affected by the other variable. Independent variable is the one that you can manipulate or that can change, and the other one will change depending on what you do with the independent variable. So for example, if I want to talk about, what can I say very easy, like how tired I am and how much sleep I had. So the time that I slept is going to be the independent variable because that's the one that I can manipulate. And the dependent variable is tiredness. So tiredness is going to be the dependent of how much time I sleep. And we have two ways to test for that hypothesis because, okay, let's continue with that example. If we have dependent variable tiredness and independent variable time hours of sleep, my hypothesis is that if I increase my hours of sleep, I will decrease my tiredness. If I decrease this, I will increase my tiredness. That is my hypothesis. The more I sleep, the less tired I am. Okay, so you can test it by saying, like, you can set your hypothesis by saying that the amount, the hours of sleep is related or correlated with how tired I am. Okay, in a hypothesis, you don't even have to mention the sign that it's going to be negative. You can just state in the hypothesis that there should be a relationship. And remember, the hypothesis has to be based on previous knowledge on literature and theory. And to test for that, because that's my hypothesis and I want to test, then I have two options, a parametric test and a non-parametric test. A parametric test is when you can assume that your sample represents the population. So then your statistic is going to be also your parameter, like we talked before. That's the first thing that we said, I think, in here with the statistic and parameter. So I moved too far. Okay, so I can choose if I am going to use a parametric test or a non-parametric test. And how can I decide that? It's very tricky, very tricky. You need to almost have your statistic book next to you to know what to do depending on your variable. So you should always have your book next to you. But a general rule is that if you have these four things, then you can use a parametric test. If it is not, if you don't have one of these, then you use a non-parametric test. But again, be careful. You have to reflect every time that you do an analysis if you are using the right tool. So let's start. It seems for parametric test, when you have a scale variable, okay? So ratio or interval. If you have a ranking, probably not the best idea to use a parametric test. That your sample, that your population has normal distribution. So that's another thing, that your population comes or has a normal distribution. Then the other thing, homogeneity of variance. It means that the variance of your sample is of both variables is not that different. Like for example, if you have one that changes a lot, like for example, this kind of tricky, like how do you measure this? Because it means that if you add more observations, your variance doesn't change that much. So it's kind of tricky to calculate that. But anyway, I think like as long as you don't have like a huge variance or zero variance, you are fine with this. This is kind of a more advanced. And then the last thing, the data values in the variable are independent. Like it is not like, for example, if I want to measure, well, if you have three variables, like if I have hours of sleep, hours of staying awake, and then tiredness. Because hours of sleep and hours and staying awake is almost the same thing, right? Like they are not independent. They are totally dependent between each other. So then this is the other thing that you should have to be careful, that your data, the data that you have, they are not, if you think that they are, especially the dependent variables, that they are independent between, but we're going to talk about that later. And to start with, this is a table that can help you to guide about what to do. If you want to test difference for independent or dependent variable, like if you want to check if, we're going to go deeper, but if you want to check if two variables are related or not, you do a t-test. That is when you have two variables. If you want to test that, but with a nominal variable, like ethnicity, gender, these kind of things, then you do a chi-square test. By definition, the chi-square test has to be non-parametric, because you can have parametric with a nominal variable. So that's kind of that's why it's a different category, because it's when you have nominal, you have to do chi-square test for independence, yes or yes. And you can't do a parametric test, but don't worry, we're going to go step by step later. If you want to test for association between two quantitative variables, any variable, if you want to test if there is association, because the thing is that this test, these three tests, the t-test and the chi-square test, they only tell you if the variables are different, like if they are not exactly the same thing, if they are related, but and if they are different, but they only tell you that, and they don't tell you how strong that relationship is. But this one, the test of association, it tells you how strong they are. And finally, if you have more than two variables ideally, but if you want to predict, or if you want to do a higher analysis that only checking for, because this tells you yes or not. Is there a relationship between the variables? Yes or not? This is the same, yes or not. This tells you how strong they are. But if you want to kind of predict, go a step forward. If you want to also analyze a multivariate sample, then you are going to do a regression, either linear or logistic. And that we're going to learn in quantitative lab. But this is kind of the levels that you have in here. This is level 1. Is there a relationship between the variables? Yes or not? Level 2, how strong is that relationship? And level 2, I want to predict, I want to go further, and I want to do an analysis of more than only two variables, one or more, okay? That is regression. So next video, we're going to start with the t-test, then we're going to move to correlation, and finally, very brief introduction to regression, but that will be mostly on the quantitative lab.